tips. One simple trick can save your Oh, hi! In this episode, I show you what I did to this cube and what it means for TPU printing, especially with softer TPU, like 85A or less. Let's go! This video is sponsored by PCBWay, more on that later. So I was asked by one of our Discord members to test 70A TPU on the Creality Ender 3 S1 Plus. We really need a name for that printer, because it uses the sprite extruder, not the Pro one, just the basic one with the PTFE lining. Because I've previously praised this extruder excessively for its normal TPU performance, it's one of the best extruders out there for TPU at this time in my opinion. It prints with zero problems on 95A, even at relatively normal printing speeds. The problem was when it came to the 70A TPU, I couldn't get a good result, and this was surprising because that doesn't make a lot of sense. A printer that prints really well with 95A just can't do 70A. I tried all the usual stuff, slowing down to around 10mm per second. It didn't work. It was still getting all these marks all over it. They just looked like severe underextrusion. Even increasing the flow to 140% wasn't really fixing it, and that's what I would normally do, and that's about the limit I would go to. There was more to it than this. But then I noticed something. Here's the thing, with the tension up to absolutely full on the extruder, using the tension setting, so that's with absolute maximum grip, which is, on this extruder, it's an insane amount, but watch. Now that's going to take some explaining, so let me try. If we look at the tensioner, which means we have to take it apart. If we look at it though, what it does is increases the tension significantly between these two gears. But, and this is a big but, the distance between the teeth can only go so small. The teeth will fully mesh here, and that will be the most you can dig into the filament. Now on PLA or PETG or any other sort of solid filament, that would be way too much tension. You would never go that far, but as I keep saying, TPU is not like PLA, and apparently it doesn't see any good reason why it needs to follow the rules. Even at full tension, it's just not well held at all. If you're already thinking ahead, then this is going to be an issue with any extruder with dual gears for exactly the same reasons. A single gear extruder with a flat opposing surface might work better. And that's kind of hilarious. Another example of just one of the many engineering challenges involved in printing with TPU. In the last video, I spoke about loosening the extruder for TPU. So if you watched that, you're probably wondering why I'm now recommending tightening it. Well, I'm not. Because everything in that video is still the case. We have stuff going on after the extruder, and we've just discovered now that there's more stuff going on before the extruder, that more than we previously realised. And so the fix is to remove that variable, to remove what's going on behind the extruder. How I did that was to pull enough loose TPU off the reel to remove the resistance, and that's the easiest solution for this printer. But of course, longer term, if you want to solve this, then you might consider bearings on the filament reel, or maybe a special low friction reel or a smaller reel for TPU. And you're definitely going to want to bypass the filament sensor. So in case you still don't know what I'm talking about, basically the force required to pull the filament off the reel and through the filament sensor in this case was too high for the amount of grip the extruder could realistically maintain. It could mostly do it, but any slippage would cause underextrusion, and of course when it tries to pull in the filament it stretches, which makes it thinner, and that is making it much more likely to slip. Does this affect ordinary 95A TPU? I would say it's likely, but the extent will depend on the setup, and most of the time, probably not noticeably. But I have had some printers with very high friction filament sensors, for example, to which I would say probably sometimes yes, even 95A will be affected. I guess we should test it to be sure. I have some ideas. Let's do that. Let's test it after the message from our sponsor, which, as you already know, is PCBWay, because I told you at the beginning, remember? It wasn't even that long ago. PCBWay does 10 colour choices in their standard PCBs and 14 for their advanced PCBs, but you could also push the boat out and have 5 colours for silkscreen too on those. I've seen some examples of these and they look amazing. In case you're a PCB ordering noob like me, the mask colour here is the pink bit and the silkscreen is the writing in white in this case, and the website is smart enough to know that you can't use white on a white PCB like here. You have to use black, and similarly white on purple. Anyway, using the quick order PCB link here makes it all easier, as for most of us the defaults are the values you're likely to need if you aren't sure what you're doing. Just upload your design and check down the list and pick a colour and away you go. PCBWay can also supply any 3D printed parts you need in a vast range of technologies that you probably won't have access to at home, and also CNC or sheet metal too. Go check out PCBWay in the link below in the description, and thank you to PCBWay for sponsoring this video. And here's the results. By the way, if I sound completely different at different parts of this video, I'm recording it over several days, so that's not usually the way I do things. But anyway, don't compare machines between each other because the cubes have been sliced differently in Cura. So, for example, the 3 grams on the Ender 3 S1 Plus is probably just higher infill or something. There's not really much to read into that. However, the same G-code has been used for that machine for every print, otherwise it wouldn't make any sense, would it? I didn't really think about this when slicing because I didn't know we were heading for a spreadsheet. You know, sometimes they creep up on you. Anyway, this is good news because it shows that the phenomenon I discovered wasn't particularly repeatable with lower elasticity filaments. You can see a bit of fall off if you really add friction to the line on some of the filaments by either moving the spool away, which is what I did where I had the heading extra friction. I was moving the spool to another printer just to add extra things in the way, or the reverse Bowden, which was about 40 centimeters or so of PTFE tube, and for TPU that actually adds quite a lot of friction, surprisingly. The point is, I think that 95A filament really isn't appearing to be terribly susceptible to pre-extruder tension, as I wouldn't expect it to be. I think I said that. Just like PLA, I don't think this is a huge factor, and this is why in the past I have completely ignored pre-extruder tensions and pre-extruder everythings, because the amount of force an extruder can pull the filament with is quite insane. It's over a kilogram. It's significantly more than that in most cases, as we saw in the last episode. So it only seems to be an issue in this special case where there is a higher elasticity and that allows the filament to thin and escape. At least that's my working hypothesis. And more slippery filaments like 40D and 70A are or can be susceptible to this. In fact, in the case of 70A, it's highly susceptible to this, to the point where you have to take measures to make sure that it doesn't happen. I did mention just now that I didn't expect to get onto spreadsheets from a simple observation about underextrusion. In fact, this started as a short video. I wasn't planning on making a full video, but obviously it escalated. So there's probably a lot more you could do here. This is still a relatively uncontrolled experiment, which I would say contains one strong learning outcome, and that would be to be careful with tension on very soft filaments. So there you go. What do you think? I personally think it's hilarious. TPU is always full of surprises, and the idea that a single gear extruder could work better, it just flies in the face of established knowledge, but it seems like there might be some truth there. But I should say that this part is still a working hypothesis. I guess I may test it at some point. Anyway, that is all for now. Remember to subscribe for more 3D printing stuff, and I will see you next time. Thank you for watching.